Today we are going to solve some problems on binary search. Here is the first problem. We have to check a number is a perfect square or not. First we discuss how can we solve like 16 is a perfect square but 17 is not a perfect square. Let's take an example of 16. We have to take two variables left and right. We have to initialize them with left equal 1 and right equal num. Right equal will be 16. We are going to solve with iteration like a for loop and while loop. First condition, if left equal right, is smaller or equal right, like 1 is smaller than 16. Then we will move to the next step. We have to calculate the mid element of that. The left plus right minus left divided by 2. 1 plus 16 minus 1 divided by 2 equal 8. Then we have to move to the next step. We have to check whether this mid is equal to our number. If it is equal, then we have to return, but it is not equal, as we can see. Then mid into mid greater than 16. Then we have to know that it is smaller than mid. The number, the square root of that number will be smaller than mid. Then we have to move the right. The right will become mid minus 1 equals 7. Then we will move to the next step. The problem is not solved. We have not found that the number is a perfect square or not. We have to check again. The left not equal to right. Left is smaller than right. Sorry, wrong condition. 1 is smaller than 7. Then we will move to the next step where the left equal to 1, right equal to 7. We have to calculate the mid like that 1 plus 7 minus 1 divided by 2. It will be mid 1 plus 3 equal 4. Mid into mid equal num. 4 into 4 equal 16. Then it will become true. We will return true for that case. Let's take an example of 17. Then we have to take a new example of 17 where we have to check the number is a perfect square or not. Initialize left equal 1, right equal num. We are going to solve this with the same condition, the left smaller than right. We calculate the mid will be 8. The mid is 64 is not equal to 16. The square of mid is greater than 16. Then we have to check in the left part of the mid, the right equal mid minus 1 equal to 8. The left is smaller or equal than right. Then we have to next step we calculate the mid. The mid into mid is 17. Here is the 16 is not equal to 17, but the mid square of mid is smaller than 16. We have to move the left. We have to check in the right part of the of that mid element. Here the left is smaller than right. 5 smaller or equal 8. The mid equal left plus right minus left divided by 2. 5 plus 8 minus 5 divided by 2. It will be 6. The 6 into 6 is a greater than 17. Then we have to move to the left right part. Then the left equal right. Left is smaller than right. Then 5 equal 5 smaller than 5. Smaller or equal, then we have to check again. The mid equal left plus right minus left divided by 2. 5 plus 5 by 5 plus 5 minus 5. 0, then it is 5. Then we have to mid into mid square not equal to 25. Mid into mid is greater than 17. We have to move the right. Then 4. The condition becomes false. The left not equal right. 5 is smaller than 4. False. We have to return false. Here is the pseudocode of it where the while where we have written the while condition. We have calculated the int equal left plus right minus left. If mid is smaller than num, return true. If mid into mid is smaller than num, left equal mid plus 1, right equal mid minus 1, Then we are moving. If we do not able to find it, we have to return it false. Here we here we have to move to the coding part of that. Here is the implement we are going to. Hello. Let's write the code for is perfect square. First, we are creating our new C++ file where we are initializing. Let's bits std_c++.h using namespace because we do not want to write std every time we write some cout scene and doing some other things. We are writing our main function cout. Just write the first we have to rewrite the logic. It will be great. Is perfect square int num. Then first initialize our two variables. Int right equal num while left is smaller than right. The first we can find our mid equal left plus right divided by left. If mid into mid equal min, return true. If mid into mid is greater than num, right equal mid minus 1 because just we are discussing our condition and L as condition left equal mid plus 1. As when we are not able to find it is the when the loop break we just return false. The outer left right for check is perfect square 9. Then we just simply write it is a perfect square. It is a perfect square. It is not a perfect square. Let's just copy this and write code for next is 10 perfect square is 16 perfect square. Where is the error? Is the error? Error is resolved. Just save it and run this code. A plus perfect dot cpp. No input file, it's perfect. Okay, I just stop it off. It's a perfect. Oh, let's just write and then cos handle is used for terminating the line and that. Like square root, as we know in the math, the square root of 9 will be 3, and the square root of 10 will be 3 point something. We have to return just 3 because we are doing the operation on the integer. Like in input 17, for input 17, we will get the output of 4. Let's solve for the input equal 9. First initialize like just we have done in the first problem, left equal 1, right equal 9. We are going to solve this with the iterative approach. Left is smaller or equal right, like left is 1 and right is 9. Left, right. And we have to find the mid. 1 plus 9 by 9 minus 1 divided by 2 equal to 5. Mid is smaller than num. No, the condition becomes false. Then we have to do the right equal mid minus 1 or right equal 4. Yeah. Because we have to find in the left side of the mid element. Uh, that's the second time iteration done. Left is smaller or equal than right, and 1 is smaller than 4. Let's move to the next part. Mid equal left plus right minus left. The mid will be 2 because 4 minus 1 equal 3 divided by 2 1 1 plus 1 2. Then check mid is smaller than num divided by mid. Yes, 2, it will be 2 is smaller than 4.5. Then we have to do answer equal mid. Left plus mid plus 1 equal 3. Then we have to move the next approach. Next iteration. Left is smaller than or equal right. Yes, 3 is smaller than 4. Then we have to do mid equal mid. Left plus right minus left. Left, right minus left. Then mid is smaller than num divided by mid. It is equal. Then we have to just do the next step. Answer equal mid and left equal mid plus 1 equal 4. The left is smaller or equal to false. The loop will break and we will return the answer equal 3. Here's the pseudocode of this. Like we initialize the variable, we have to use the loop because we are using while loop. Mid equal left plus right minus left divided by 2. Answer mid if like we have written our condition and what will happen in the condition. Answer equal mid, left equal mid plus 1, and for the else condition right equal mid minus 1, and after the everything like condition breaks then return the answer. Let's move to the implementation part of this. X square root of x dot cpp has include bits plus stdc++ using namespace std int main. First, we are writing our logic for that. Square root int num. Int left equal 1, right equal num. We are writing our left smaller than or equal to right. Int mid equal left plus right minus left divided by 2. If mid is smaller or equal num mid by 2, then what will happen? Answer equal mid, left equal mid plus 1. Okay, why we are getting our red squiggly because we have not declared answer. Else right equal mid minus 1. Just return answer. See output square root 9. See out square root and then the out square root 70 and then let's run our code. G++ square root of CPP. A dot out. The square root of 9, just like I have square root of 9, 3, square root of 10, 3, square root of 17, 4. There is the whole implementation of the square root using binary search. Okay, thank you for watching my video. Here today we have solved our two problems of binary search. Okay, thanks. Have a nice day.